Alright, in this video we're going to look at converting from polar coordinates to rectangular coordinates. In other words, if we look at those points that we plotted in example 1, being able to determine what the x and y coordinates for those points would be. Alright, so converting from polar to rectangular, and even in the next video when we look at rectangular to polar, involves trig functions of any angle. So I've mentioned several times that it's one of the most important sections in trigonometry, and there's a good reason for that. So with polar to rectangular, we're going to know what the value of r and what the angle theta measurement is going to be, much like we did in example 1. What we want to do is be able to go from knowing what this red length is and this angle measurement to knowing what the x and y coordinates of this point are. So this point, and for demonstration purposes, it's just a point in the first quadrant, but it could be in any quadrant. If we know the length of this hypotenuse and the angle measurement, then we can use some right triangle or some trig functions of any angle to figure out what the x and y coordinates are. So your cosine of your angle that you're told is the x coordinate over r, and the sine of this angle that you'll know is the y coordinate over r. So if we multiply both sides by r in each one of these equations, we get the x coordinate is r cosine theta, and the y coordinate is r sine theta. So that's how you go from knowing what the polar form is to getting the rectangular or the x and y form. So example 2, we're going to convert each of the following to rectangular coordinates. So we have an r value of 2 and an angle of rotation of 270 degrees. So the x coordinate is going to be 2 cosine 270 degrees. The y coordinate is going to be 2 times the sine of 270 degrees. So cosine of 270 is 0, sine of 270 is negative 1, and we get 0 for x and negative 2 for y. So our rectangular coordinates are at 0, 2, which if we were to plot the original, going out 2 and then rotating 270 degrees, this is where we would end up at this point right here. Well, going from polar to rectangular, if we, instead of having rings, these solid rings, we think of these as tick marks on the x-axis and y-axis, then this point here would be 2 tick marks below the origin, which is at 0, 2. So we can replace those rings with these tick marks, and that's essentially all the difference is. We just swap out the axes, the x and y axes, for polar axes, but more or less it's the same, pretty much the same thing. All right, example 2, we have the point negative 8 and pi over 3. So x coordinate is going to equal negative 8 times the cosine of pi over 3, and our y coordinate is going to equal negative 8 times the sine of pi over 3. So cosine of pi over 3 is a half, so negative 8 times a half for x. Sine of pi over 3 is square root of 3 over 2, so negative 8 times the square root of 3 over 2 for y. Half of negative 8 for x is negative 4. Half of negative 8 is 4, and then negative 4 rather, and that negative 4 times the square root of 3 gives us a y value of negative 4 square root of 3. So our x and y representation of the polar point, negative 8 pi over 3, is negative 4 and negative 4 square root of 3. Alright, that about does it for this video. In the next video, we're going to go from rectangular form to polar form. So we're essentially just going to start with this answer and learn how to work our way backwards to get this polar representation. So I'll see you then.